How does the electronic control module in a car, ECM, control the alternator? Are you curious about how your vehicle's electrical parts stay powered and running smoothly while you drive? Well, it all starts with the alternator, which provides power to various parts of your car, like the battery, ignition system, lighting systems, like interior and exterior lights, headlights and radio, etc. Well, all these are controlled and regulated by the ECM, which stands for Electronic Control Module. In this video, we'll explore how ECMs regulate the current and voltage output of an alternator, and we'll dive into the various parts and sensors that make it all possible. So sit back, and let's discover how ECM controls the alternator. Before we get started, take a moment to subscribe to our channel and turn on the bell icon so you don't miss a video from me. The alternator system provides power to the vehicle's electrical components, including its battery. In most vehicles today, this system is controlled by the Powertrain Control Module, PCM. ECMs are responsible for regulating the current and voltage output of an alternator, which is essential for keeping your vehicle running smoothly. So here's how ECM control works. The ECM sends out signals that tell the alternator what type of electrical load needs to be generated. This signal varies depending on how much energy is needed by various components in your vehicle, such as lights and power windows. The amount of electricity generated by the alternator must match this demand, or else there could be problems with performance or even damage to other components due to overloading them with too much electricity. Once these signals have been received from the ECM, they're sent back through a series of sensors located within both internal parts and external wiring harnesses connected directly between them both, which measure any changes in voltage or current levels so that adjustments can be made. To control an alternator effectively, ECMs look at several different inputs, including vehicle speed, RPM, battery voltage level, voltage regulator, and temperature sensors on both sides of the cooling system radiator fan clutch switch points. Based on this information, it will adjust the current output so as not to overcharge or undercharge a battery, which could lead to damage. What controls the alternator current? The main controller of alternator current is a device known as a voltage regulator. This device monitors the output voltage from your alternator and ensures that it does not exceed its rated value by controlling how much current flow through it. The voltage regulator also prevents too much or too little charge from flowing into your battery, which can cause damage. To ensure proper operation, you need to make sure your car's charging system has been properly set up with the right size fuses and wiring in place so that no more than 14 volts reach your battery at any given time, the ideal range being between 13 and 14 volts. If there isn't enough resistance in place, too much electricity will flow across, causing potential damage or even a fire hazard. What main computer controls alternator functions? It's within the Engine Control Unit, ECU. The ECU monitors various engine parameters, such as speed, temperature, and fuel consumption, and adjusts settings to ensure optimal performance. In addition to controlling engine functions, it also manages many other components, including the alternator. The ECU receives data from sensors located in your vehicle's electrical system and uses this data to adjust voltage output from the alternator so that it can maintain battery charge levels while providing adequate power for all of its components at any given time. It will also monitor how much current is being drawn from each component so that no single device drains too much power or causes an overload situation where too little energy remains available for other systems in need of electricity. Does the alternator power? The ECM? The alternator does power up an automobile's engine control module, ECM. Without this key component providing electricity to its circuits, many essential operations within an engine would cease functioning correctly, leading to poor performance or even complete breakdown. The alternator is responsible for generating electricity to keep all of the electrical systems in your car running properly. It does so by converting mechanical energy from a rotating shaft into electric current, which can then be used in different parts of your vehicle. This electric current also powers up any computerized control modules like ECMs that help manage engine functions like fuel injection timing and spark plug firing sequence, among others. What activates the alternator? In most vehicles, it's a belt connected to the crankshaft pulley that turns on and off when you start or stop your car. This belt transfers energy from the crankshaft to spin up an internal rotor inside your alternator, which in turn creates electricity for use by other components, such as headlights, radios, and air conditioning systems. Another key component required for the proper functioning of an alternator is the voltage regulator, a small circuit board located near or within its housing that maintains consistent output, regardless of input voltage changes from the battery or other sources. Which component controls the output of an alternator? There are a combination of components, including a voltage regulator, a diode rectifier assembly, and brushes. The voltage regulator monitors battery voltage levels and adjusts current flow accordingly. This ensures that too much or too little electricity isn't produced by the alternator. The diode rectifier assembly converts alternating current, AC, from the rotor into direct current, DC, which can then be used to charge your battery or power other systems on board your vehicle. What are the two ways to control alternator output? There are two primary ways that DC alternator output can be controlled: through a voltage regulator and a current limiter. A voltage regulator is responsible for maintaining the correct amount of voltage for other components within the system to function properly. It does this by sensing when there is too much or too little electricity being produced by the alternator and then adjusting its internal settings within your electrical system to remain balanced and functioning optimally. On the other hand, current limiters are designed specifically with safety in mind. They help prevent overloading circuits with excessive amounts of electricity, which could potentially cause damage or even start fires if not monitored closely enough. Conclusion: the electronic control module, ECM, plays an important role in the car. With its sophisticated algorithms and programming logic, it can regulate voltage output from the alternator while also monitoring engine speed to ensure optimal performance at all times. The ECM acts as a bridge between the battery and alternator by sending signals back and forth between them via sensors located on either device. This allows for accurate readings, which are then used to adjust voltage levels depending on how much current is drained from each source, ensuring that your vehicle's electrical system runs smoothly without overloading or underperforming due to an imbalance in power supply and demand ratio. I hope you found this video to be informative and valuable. Please subscribe to our channel and don't forget to like this video to support the channel. Thank you for watching. I will see you in my next upload. Bye.